Good morning, good afternoon, good evening from whichever location you are watching Questpon's YouTube channel. A very warm welcome to everyone. So what are we doing today? Today we will be learning the basics of data science, machine learning, artificial intelligence, statistics, Python, R, and so on in flat 1 hour. Yes, you guessed it right, in flat 1 hour. If you stick with me till the end of 1 hour, I can guarantee you will know the fundamentals of data science, machine learning, AI, but also you will have the know-how of Python. You would have Python and R installed in your computer, and also you would have executed some statistical formulas using R and Python. So stick with me for an hour and rest assured that you are into the data science industry. Now, let me also explain you that how is this 1 hour of teaching format is. So the format of this 1 hour of teaching has chapters and has labs. So chapters have theories and fundamentals, while labs have practicals. So there are 18 chapters, and in these 18 chapters, we have 4 labs. So in this 1 hour, what I've done is I have dedicated the first 30 minutes for fundamentals and theory, and the rest 30 minutes for practical. So till lab 12, you will see me discussing about various jargons, vocabularies, what are discussed in the data science and the AI industry. And then we will be executing labs using Python and R programming. And in all of these 4 labs, what I'm trying to do is I'm trying to execute the linear regression statistical formula with Excel, with Python, with R. So I have demonstrated the linear regression using all of these 3 tools. So with this, till the end of the tutorial, you are ready with the necessary things to start with data science. But before we start with anything, let us start with chapter 1, the first chapter, the meaning of artificial intelligence, the definition of artificial intelligence. Data science, machine learning, deep learning, data scientist, business intelligence, data analyst, and a lot of these things, keywords, or you can say buzzwords, have emerged from one single initiative, and that is artificial intelligence. So all of these things actually belongs to a single umbrella, artificial intelligence. So let's first define what exactly is artificial intelligence. Artificial intelligence is an area of study with one goal, one main goal, that is creating intelligent computer machines which can think, work, and react like humans. So if you see around, humans have been fantasizing about this machine acting like humans. There are a lot of movies which have been created around the same. Also, you can see many applications created with the same goal. For example, Siri, Alexa, Cortana, Google Help, and so on. Humans have tried various ways to implement artificial intelligence. There are developers who have created complex rules engine. People have created knowledge base, knowledge graphs, and so on. Even a simple if-else condition, which you can see on my screen, is an attempt to achieve the goal of artificial intelligence. So let us try to analyze, can we achieve the goal of artificial intelligence using simple programming? For example, you can see on my screen there is a simple program out here which takes in the sentiments, and depending on the sentiments, the machine reacts back. So if you put a sentiment which is good, it will react back that it is nice. If you put a sentiment bad, it will react back accordingly, right? So this is a simple C# program out here, which is a simple if-else condition. And so if I put here good, it gives me this is nice. If you put bad, it actually reacts accordingly. Now, let us say tomorrow if I want to add a new sentiment, for example, let us say if I want to add a sentiment called as worst, right? Or something like worst, I need to go ahead and make some code changes. So I will go here, I will add these extra lines of code, and then my code knows how to react to the sentiment worst. So let's try to analyze. Can we achieve artificial intelligence by using just a simple if-else condition, or probably by creating some kind of a complex rule engine, or by having some kind of a knowledge graph and so on? So if you look back, the goal of artificial intelligence, it is to make machines think like humans. And one of the biggest things about humans is learning and maturing, self-learning and maturing. This is the biggest thing about humans. So humans learn from their parents, they learn from their teachers, they learn from their surroundings, and whatever knowledge they get from all of these, they make a better decision. So if we want really to achieve artificial intelligence, then our code should have the ability to learn from something. It should be self-learning. So rather than developer going and changing the code every time, we want that our code should try to do self-learning. So machine learning is a process, where we train our code algorithm by using training data. So we provide training data and the code becomes better and better in terms of judgment and in terms of decision making by learning from that training data. So we can also say that in machine learning, we have self-learning algorithms. So summarizing, we have a big umbrella, the big goal, the big fantasy of humans of artificial intelligence. And to achieve the same, we apply machine learning, which is nothing but algorithms getting trained by training data. So we can also summarize, every code what you write there for achieving AI is not necessary that it is a machine learning code, right? So yes, you have AI, and to implement AI, I can use if-else conditions. I can write a complex logic, a complex rules engine. I can have some kind of a big, a big knowledge graph, right? I can have databases for it. But at the end of the day, machine learning, has a very specific quality of self-learning, learning from training data. There, we do not do any kind of code changes. So you can see on the screen, I'm flashing up that yes, the big umbrella is AI. And to implement that, there are various ways of doing it. And machine learning is the most prominent way of achieving AI. Let us spend 2-3 minutes in understanding in depth the machine learning process. I personally have named this machine learning process as the TAMA process. So TAMA is the acronym of the different phases in machine learning. So we have the first acronym is the first word is the T, then we have the A, then we have the M, and then we have the A. So in other words, we have this step 1. So in step 1 in machine learning, what happens is you use your training data, right? And you train an algorithm. So basically in step 1, you get your training data. In step 2, you take this training data and you run over this algorithm. Step 3, the output of running this training data over the algorithm, you get an output, something called as the model, right? And in step 4, what you do is that you assure that this model is as per your specification. So this TAMA is a process, wherein first we have training data. Second, we take this training data and we run over the algorithm. And the output what we get is a model. And then we go ahead and we assure that this model is as per our requirement. It is up to the mark. Whatever inputs we are giving to him, he is actually giving us proper outputs. And in case if we see that this model is not right, then we go ahead and we iterate step 1. So we again go ahead and we iterate step 1. Now, in order to set up this TAMA process, or I'll say to set up this whole machine learning infrastructure, or we can say ecosystem, we need to have knowledge from multiple fields. We need knowledge which is multidisciplinary. For example, let me go and add a column here. What skills do we need, right? So for example, if you look at step 1, in order to organize training data, probably I need knowledge of RDBMS. I will need knowledge of ETL, how to extract it, transform it, load it. So in other words, I will need a proper IT knowledge of understanding data, of loading data, massaging data, and so on, right? The second step, look at the second step, algorithms. So over here, I should have some understanding of maths, and specifically we can say statistics. Look at the fourth step. Once the model is created, we need to test the model. We need to check that this model is right or wrong, right? So for this, we need proper domain knowledge for which we are creating this machine learning process. So when you say that you want to implement a proper machine learning infrastructure or an ecosystem, you need multidisciplinary knowledge. You need IT knowledge. You need knowledge of maths, statistics. You need the domain knowledge, and so on. And this is what is the area of data science. Data science is a field which focuses on extracting information from data. So on the screen, you can see we have a sample data. Now, Generally speaking, data will be of huge size and with millions of record. But because we are learning at this moment, let us try to concentrate on this simple sample data. Let us understand how data science functions. Let us understand the fundamentals of data science first, and then we will go and look at a larger record set. Now, this sample data, which you can see on the screen, is a recorded reading of how many people can lift how much weight. So if it is 3 people, they can lift 63 kg. If it is 10 people, they can lift 203 kg, and so on. So now we need to figure out the relationship between the number of people and the weight lifted, so that if we know the number of people, we can estimate how much weight can be lifted, and if we know the weight, we can estimate how many people we need to hire. So to figure out the relationship between weight and number of people, we will use some maths, or to be specific, we will use statistical maths, and to be more specific, we will use regression analysis, and to be exactly specific, we will use something called as linear regression. For now, do not stress yourself with what is statistics, regression, linear regression. In the later classes, I will have dedicated chapters for maths. So do not get discouraged at how much maths we have to learn, and how much maths we should know. In my later labs, we will teach you the necessary maths which is needed to be known for data science. For now, just note that regression is a part of statistical maths which helps us to determine relationship between two data. So for example, over here we have these two records, right? These two columns, I will say, and regression analysis or the linear regression will help us to figure out, what is the relationship between both of these columns. Linear regression says that if you have two variables, and if these variables are scalar and continuous numeric in nature, means in other words, they have numbers, and if there is a relationship between these two data, then that relationship can be expressed by the linear equation y is equal to mx plus c. So over here what we can do is, let's say that this is the y which we want to figure out, and this is the x, right? So this is the y and this is the x, right? So linear regression says that if you have two variables which are scalar, numeric, continuous, then this equation will help you out to come out with the relationship. In this equation, this m stands for the slope and this c stands for the intercept. So basically you want to figure out the y, and to figure out the y, so you want to figure out the y, and to figure out the y you will give the x, and you need to go ahead and now decide, or now you need to calculate what will be the m and the c. Now this m is nothing but the slope. So what I will do is, in order to calculate the slope, I will use the slope formula which is given in Excel. So you can see I'm using the slope formula. But if you want to go and calculate manually, you can see on the screen I have flashed how to calculate the slope, right? So and later on, as I've said, that we are going to go and do this maths thing, so we don't have to worry. But at this moment, let us try to ease our task by using the Excel formulas. So I will say that, okay, these are the known y. So you can see this is the known y. You can see the slope formula takes two inputs, known y's and known x. So known y I have given, also I am giving him the known x. So that is the slope calculated. If you want to calculate the intercept, again you need to give the known y, and also you need to give the known x. Again, you can see on the screen I'm flashing the calculations. If you wish to do it manually, take up a calculator and try to see if the values are matching. So now what is y? Y says that whatever is the slope m into whatever is the x given plus the intercept. So now you can see here we have come out with a formula which says y is equal to 20x plus 3. Right? So in other words, now let's go ahead and test if this equation works. So let us say if I put 3 here, you can see it is showing the weight as 63, which is right. If I put 10, it is showing 203. So you can see now our values are matching by the data what is given, right? So this formula looks right. If you try to visualize what are the steps, taken in the last 3-4 minutes. In the last 3-4 minutes, what did we do? In the last 3-4 minutes, if you see, we had this historical data of number of people versus the weight lifted. We use this historical data, and to figure out the relationship between the data, we use maths. So basically we use statistical maths and we use linear regression. To calculate linear regression, we used our Excel skills. We used our IT skills of Excel formula. So to calculate the slope and to calculate the intercept, we use the Excel formulas. We also used our domain expertise out here to ensure that, whatever is the output coming, it is right or not, right? So basically we used our general domain expertise to check that when we give the number of people, the weight lifted is coming right or not. This is termed as data science. So in other words, data science is a multidisciplinary field. It's a multidisciplinary field means it involves IT skills like simple Excel formulas to must be a complex Python program or R program. It involves statistical maths and it involves domain expertise. So data science is a multidisciplinary field which focuses on extracting information from data. So this is the data and this is the information we have extracted, right? So it is a multidisciplinary field which helps us to extract information from data. And in this multidisciplinary field, we need IT knowledge, we need statistical maths, and we need domain expertise. There is one more important concept which we need to understand, and we need to understand the differentiation between them is supervised learning and non-supervised learning. Both of these learnings are part of machine learning. So as the name says, supervised, we know upfront a lot of things. We know the inputs, we know the outputs. We also know what functions to connect the inputs and the outputs. The only thing we do in supervised learning is we try to make the prediction of the function better. For example, in this example, we knew that these two inputs very well. We knew that these two inputs are connected, by the way of linear regression. So we knew the inputs, we knew that what kind of output we want. And the only thing what we were doing out here is we were trying to make our slope and intercept better. So in other words, we were trying to make these two things better, and that will help us to make our function more better in terms of prediction. So in supervised learning, we know the inputs, we know the outputs. We also know, what kind of functions can connect the inputs and the outputs. And the only thing what we do is that we try to make this function better. But now let us say I give you a data set which is like this, something like this. And I say that go ahead and try to see that what we can do from this data set. So in unsupervised learning, we only know the input. We have no idea what can be the output, and we try to hunt a pattern. So in supervised learning, we know the function and we try to make that function better. But while in case of unsupervised learning, we only know the input and we try to hunt a pattern. Now from the algorithm perspective, in supervised learning, we have algorithms like regression, linear, classification, while in unsupervised, we have algorithms like clustering, association, means, and so on, k-means, and so on, right? So you can see in this Excel sheet, you can download it, from the link given in the video tutorial. So in this Excel sheet, I have practice one. This practice one actually has linear regression. So this is supervised learning, linear regression. And what I will do is in practice 2 sheet, let us go ahead and apply clustering. So this practice 2 sheet is of example of unsupervised learning. So on this we will go and we'll apply clustering. Now please note that at this moment I'm using Excel to demonstrate the ability of machine learning, to demonstrate some of the statistical part here. But definitely when it comes to large data set, Excel is not really capable of it. So at that time we definitely need to use Python. we need to use R and so on. So in the further coming lectures, I'm going to go and cover Python as well. I will cover R as well, right? So for now, just be cool and calm and first try to get the fundamentals, because if you don't understand all these vocabularies like supervised learning, unsupervised learning, data mining, deep learning, machine learning, and so on, if you don't understand the vocabulary part of it, it can become very confusing when we start R and Python, right? So for now, just take a deep breath, go slow, and rest. Everything is assured that as we move ahead, we will be covering all these things using Python and R. So this is the unsupervised learning data set, and as we said, the whole goal of unsupervised learning is to hunt out a pattern. So let us see that if we can go and hunt out a pattern from this data set. But before that, the first thing is I would like to know that is there any relationship between these columns? For example, is there a relationship between age and between shopping amount, or between age and the weight, right? So is there any kind of relationship, right? So what I will do is, let me go ahead here and say, okay, does age and weight have any relationship? Does age and shopping amount has relationship, right? Does weight and shopping amount has any relationship? So weight and shopping amount. So first thing is, let us figure out that is there any relationship between these columns, because once we know that there is a relationship between the columns, then we can go and use only those columns to hunt the pattern, right? So at this moment, I know that by using your naked eyes, you can figure out that there is a relationship, right, between the age and amount. But think about that, if you have millions of records, it is difficult, humanly to know that if there is any connection between two columns, right? So let us go ahead and use the correlation function. So you can see there is something called as a correlation coefficient. This correlation coefficient says, it's again a statistical equation from in maths, which tells that how close are two columns related or two data set related, right? So I'll go and give him the array 1. I will go and give him the array 2, right? In the same way, let us go ahead and apply correlation function for this is age and I did this for age, and this is age and weight. I'm sorry. So age and weight, right? Let's say correlation for this is age and shopping amount, right? And definitely you can go and make this more dynamic by using some programming language, right? So at this moment, I'm doing it in a hard-coded way, but in Python, you can go and read all the columns and do it more dynamic, right? So correlation, again, now I want to see that if there is any relationship between the shopping amount and the weight. Good. So you can see now the age and the weight, we have got the correlation coefficient as 0.35, age and shopping amount is 0.9, and the weight is and shopping is 0.33. So in the correlation coefficient says that the more you are nearer to 1, the more there is a tight relationship. So from here I can now make out that age and the shopping amount is having a very deep connection, right? So we should be trying to hunt pattern between the age and the shopping amount. The other twos are 0.30 and 0.30, right? And this one is quite high, right? So this has, these two columns have the highest affinity of, getting pattern, right? So let us now, so now that we have zeroed on this column, so the weight column, at this moment is excluded from our pattern hunting mechanism, and we should only concentrate on these two columns. Now to apply clustering in Excel, or to use the clustering algorithm in Excel, there is no straightforward way of doing it. In other words, we do not have any algorithm saying, do not have any formula saying cluster and find out, right? But definitely in R and Python, there are definitely very better ways of doing it. So what we'll do out here is we'll be using the scatter plot. So we'll be using the scatter plot out here, the scatter chart, I will say rather, and we will try to see the patterns visually. Okay. Now, please note again, I'm saying data science is an art. So it is not that I have to use only R, I have to use only Python, I have to use only statistical maths. It can also be seeing things visually and understanding that how your data is and how you can extract information from the data. So data science is an art. It is an art, which takes lots of tool sets, which definitely says that, okay, you have to understand math, statistical modeling, but at the same time, you can use unorthodox ways of doing it, because sometimes your data is sometimes so weird that probably you will end up with unorthodox way of detecting patterns of extracting information from that data, right? So at this moment, I'm using the scatter plot to detect our pattern, right? So let us go ahead and I will say select data out here and let us add, so this X value is this. Let us take this X value and the Y value is this. So let us take the Y value, right? And we'll say okay, right? So here it is. Okay, so you can see now we are seeing something out here, and so let's say this is detecting patterns, right? It is clustering. Okay, so you can see out here, I can see that there's a small group of dots right out here. Let's go ahead and select these dots and let's make them much better so that I can see them better. So what I will do is I will make it a solid fill so that we can see it properly. Yeah, that looks good. I don't want any kind of grid lines, so can we get rid of, so no lines, right? Okay, no grids. Is there a way of just getting away with the grids? I don't see that. Okay, let's see out here. No line. I don't want any line. Okay, right. Just trying to make it better. Oh, I'm seeing too many lines out there. So no line. Right. Okay. I just want to make sure that this line goes off. It is looking horrible to read. Okay. Somewhere. Actually, I wanted to just get rid of these grid lines out here. Okay. Oh no, I want that. I want that. Okay, I did something. I want that axis. Yeah, fine. So basically what I was trying to do is I was trying to get off this grid. I was trying to get rid of this grid lines so that we can see this clustering in a more visual way. But definitely what I can see out here is that there is a small cluster formed here. There is a small cluster formed here. There is a small cluster formed here, right? So for example, I can see here that for the age of till the age of 20 and the amount of 50. Also what we can do is we can get rid of this gaps out here. So basically I can, let's say I can go and say what I'm not comfortable is okay, so is it possible to start from 50, because this is big lines out here, so that I can 50. Yeah, okay, so that's good. Now things are more better, right? So what I've done is I've just removed the areas where there is no data, right? So but I can clearly see that there is a cluster here, there's a cluster here, there's a cluster here, right? So now what I can do is I can say, okay, from all this hunting, from all these patterns, I have come out with a category, and I have one category which is specifically of the customers who are of the age 20 and they shop between 0 to 50, right? So this is category 1, right? Category 1. This again goes in category 1. Definitely, this what I'm doing now manually, you will be doing through a program, right? So again, you can see this is age 20, category 1. This goes in, right? The other category is like 35 to 40 age, and so 35 to 48. So this is category 2. This is category 2, and again this is category 2, right? And this is category 2, and this is category 2, right? And then we have this 40 to 50 age, and they shop between 200 to 220. So this is category 3. This is category 3, and this is category 3, right? So you can see now what happened here. Basically this is an example of unsupervised learning. We had a data, we ran the clustering algorithm over it, Definitely, I did not run any clustering algorithm. I did it visually for now. But when we do Python, we will see that how we can go and run clustering algorithm through a formula, right? But I went ahead, I saw that there are 3 clusters, which I detected. And now I have a better understanding of my data that yes, that this is category 1. Now you can name this category 1 as normal customers because they buy less amount. The category 2, are more like gold customers must be, right? And the category 3 are more premium customers. So basically what has happened now is in unsupervised learning, we went ahead and we tried to hunt out a pattern. So in unsupervised learning, we try to hunt out a pattern. In supervised learning, we try to make our formula or our function much better so that we can do better predictions. Also, I would like to discuss about one more confusing vocabulary, data mining. Now, mining in English means to hunt something. In the same way, data mining in AI means to hunt a pattern in a huge data set. So data mining and unsupervised learnings are synonyms. So when someone says that this is unsupervised learning, then he also means that this is data mining. And when someone says data mining, it means unsupervised learning. One more vocabulary which is discussed a lot is deep learning. Now, if we want machines to really work and think like humans, then we should start thinking like the human brain. And also our technical architecture should replicate the human brain architecture. Now, if you see a human brain, the way information flows throughout the body, it uses something called as the neurons. Neurons detect, what is going around us and inside us, and they decide, how the body should act depending on the input. So if you see a human brain, it has like 86 billion neurons, which has layers of network. Every network doing some specialized task and passing the output of that network's task to the next network and finally telling the body how to act. This is termed as the neural network. Deep learning tries to mimic the human neural network thought process. It has multiple layers of thought process and every layer focuses on specific task. And it passes the output of that network as an input to another network and finally arriving to a decision. For instance, let us say we have created a deep learning logic for detecting bank fraud transaction. So we can have first layer which will detect the history of the account holder, whether the account holder has some previous fraud history. The output of this layer will go to the input of the next layer. Now let us say that the next layer is dedicated to check for absurdness. Absurdness means, is this transaction coming from a far away geolocation? Are the timings weird? Is the transaction amount weird? And so on. So this layer will check for absurdness and this will be passed to the next layer and so on until we finally conclude that this transaction is fraud or not. So deep learning is nothing but it has a neural network and it is one of the forms of machine learning. We can also say deep learning is a subset of machine learning. So let's try to summarize, what we have learned in the past 30 minutes. So here is a 30,000 feet view of the overall things we have discussed in the past 30 minutes. So at the top, we have this important mission, this main goal, AI, where we want machines to act like humans. So all of these things, data science, machine learning, supervised learning, unsupervised learning, data mining, everything has started, with that one goal in mind where we want machines to think like humans. Now, AI can be implemented by simple if-else conditions. It can be implemented by a knowledge graph. It can be implemented by various coding techniques, but machine learning stands at the top. Why? Because in machine learning, we do not believe in code changes, but we want that the code should learn from the data. So in machine learning, we have the training data. The training data goes and trains the algorithm. So it basically goes and trains an algorithm. And from there, we get something called as a model. And this model, we again go and we test by using the test data. And if we find that the model is not appropriate, we again go and we rehash our training data. We make our training data better. And again, we try to execute this cycle. And if you remember, I said that this whole cycle is termed as the TAMA process. So we have training, then we have the algorithm, then we have, the model, and then assuring that this model is right. Now, again, there are two subcategories in machine learning. One is supervised learning. In supervised learning, we have the training data. we have the inputs, we know the inputs, we know the functions, the algorithms, we also know, what kind of expected output we want. And the whole goal in supervised learning is to ensure that this function, this algorithm, becomes better in terms of prediction. So for example, if you remember, we had this equation of y equal to mx plus c. What we were trying to do in supervised learning is we were just trying to make that m and the c, that is the slope and the intercept values, much better. So this is termed as supervised learning, where we know the inputs, where we know the outputs, where we know the function. Unsupervised learning, or we can say data mining, is where basically we go and we try to hunt a pattern. And once we figure out this pattern, we can probably give it as a feedback to our supervised learning, or we can make our algorithm better in supervised learning, right? So unsupervised learning is all about hunting a pattern, and supervised learning is all about making your functions, your algorithms, much more better in terms of prediction. Then we have the other side, the data science. Data science is all about extracting information from data. So it's a multidisciplinary field, wherein we need to have IT knowledge, we need to have database knowledge, SQL, we need to have programming knowledge like Python, R, or must be Excel knowledge. We need to have domain knowledge, we need to have statistical maths knowledge. So it's a multidisciplinary field, wherein we take all of these things and we try to extract information from data. And again, this information will be fed into the machine learning ecosystem to make machine learning better. So for example, from this information, if probably you can come out with the equation or come out with a formula, and that formula can become a part of algorithm. From this information, you can probably hunt a pattern, and that pattern can become as an input to unsupervised learning. So data science, basically tries to extract information from the data, and then that can become a part of machine learning. So this is a 30,000 feet level of how AI, ML, supervised learning, unsupervised learning, data science, everything fits in. So now the next question which can come to your mind is, so can we implement machine learning, artificial intelligence, data science using Excel? The answer is no. Yes, you can learn and understand the concepts of machine learning using Excel. In my tutorial, so I'm going to go and use Excel a lot, but that is only for understanding purpose. When you talk about production level work, it is not feasible with Excel, because Excel can handle like 100,000 records. So when you're talking about data in ML, in data science, in machine learning, it's of huge size. It is like millions and billions of record. So we need a proper database, a proper programming language to process such huge kind of data. And that's where Python comes to rescue. The next question that would come to your mind is, why Python? And why not C++, and why not Java, and why not C#, and so on? There are so many good languages out there. They are there for years together. They are backed by big organization. So why Python? So if you're just saying from pure programming language aspect, I think all languages are good and equivalent. So if there is a famous programming language out there like C++ and Java and C# and Python, I think everyone is great, because or else they won't have ranked as the top languages, right? So they all have equivalent capabilities. But when you talk about artificial intelligence, data science, machine learning, you need some extra capabilities. This is not like developing a web application or developing a desktop application, right? It is different. When you say machine learning, you need, that there should be ready-made algorithmic functions. You don't want to write linear regression from scratch, right? You want all the statistical functions should be inbuilt, time tested, there should not be any errors. You need a way to handle large data sets. You need a way to display graphs and patterns. So basically, more than programming language, you need a lot of other features, which is needed for implementing good machine learning. All these features, I term it as the LAMP feature. This LAMP is my personal acronym. So where the L stands for handling large data sets, A stands for ready-made algorithms, M stands for manipulating large data sets, and the P stands for displaying graph and patterns. Now, when you talk about Python, Python has lots of frameworks and libraries. So we have scipy, we have matlib, we have pandas, and so on. So there are so many ready-made libraries out there, which makes Python a great language for data science. If you talk about C# and Java and C++, they do have some maths function, but that is like log, square root, and so on. but they do not have algorithm function like time series, linear regression and so on, right? That's all there in Python inbuilt. So that makes Python the language of data science, the language of AI, the language of machine learning. So let us go ahead now and let us install Python and let us see how Python looks like, and let us try to run our first Python program. To install Python, you can go to python.org website and you can see the downloads over here. Now at this moment, the first thing I'm installing is the Python framework. So to install Python framework, we need to go to python.org, go to downloads, and you can see the recent version is 3.7.2. Now please note that at this moment my operating system is Windows, so I'm installing the Windows version. In case it is Mac, then you should go accordingly. In case it is Linux or other platforms, you have to go accordingly. If you click on downloads out here, it again takes to a much larger screen, where you can go and say click on Windows, click on Linux. So if I click on Windows, it shows me the latest release at the top. So if I click on 3.7.2, it takes me to this page, and this page gives me a lot of options. So you can see there is a Mac 64-bit installer, there is a Mac 32-bit installer, there is a Windows 64-bit installer, and there is a Windows 32-bit installer, that is x86, right? So depending on what kind of operating system you have, you should install the appropriate installer. For example, at this moment, mine is a Windows version. Mine is a Windows operating system, and my machine is 64-bit. So you can see I went to the properties of my computer and you can see 64-bit, right? So for me, this is the appropriate installer, x86 64 executable. In case if yours is a 32-bit, must be this is the installer, right? So depending on your operating system, depending on your 64-bit or 32-bit, please go ahead and install the Python framework. Once you install the Python framework, you should be able to see this thing out here. Like you can see Python desktop app, right? And if you click on that, it opens up something like this out here. And over here, you can go and you can type the Python command. So for example, I can say print, this is my first Python code, right? So that should go ahead and print it. If you want to declare a variable, you can say x is equal to 0. If you want to just do something like x plus 1, again, I can say x plus 1, and then I can say print x. So this small command window out here, you can go ahead and you can just test, if your Python is installed and if it is working. So the first step is install the Python framework and ensure that your Python framework is installed properly. Now, definitely, when you talk about enterprise projects, big projects, you can't code using an interpreter like this, right? In other words, you can't code through a terminal like this. You really need to create a project. You need an IDE, you need IntelliSense, you need an editor, right? So for that, we have this famous tool, which is specifically for Python, which is been used by the community of Python large, which is the pycharm. Pycharm is actually created by JetBrains. So you can see in pycharm, we have two downloads. One is the professional edition. For this, you need to pay later on. And the other one is the community edition. And this is free and open source. So go ahead and download the community edition. Once you download the community edition, you would get something like this. So let me close this. So once you download, you can go ahead and search for JetBrains. You can see over here, this JetBrains pycharm community edition has been installed. And if you click on it, the pycharm will open. So first thing is you need to go ahead and install the Python framework, right? And test that if the Python framework is running by this small terminal out here. Once you're done with that, then the next thing is you need to go ahead and install pycharm, from JetBrains. And this pycharm you can download from jetbrains.com. You can see out here, you can Google pycharm. So if you just Google pycharm download, you would get the first link, and this first link actually points towards the download of pycharm, right? And once you install it, you can go and you can search for JetBrains pycharm community edition, and you would get something like this, right? Okay. Now you can see that I had created some basic project out there. That is one thing, and the next thing is the fonts are not really looking great out here, right? So let me go ahead and just make the fonts bigger. So I'm going to go to settings out here, and I will just appearance and behavior, and in appearance, let me just use some custom fonts. I'll say, okay, make it 22 so that we can see the code better. Yeah, that looks better, I guess, right? Okay, so the fonts look better out here. So now to create a project, so first thing is we need, if you want to code anything using pycharm, you need to first go and create a project. So I'm going to go and create a project out here. You can see the directory, and I will give the name as Python lab 1, right? So this is lab 1, and we'll go ahead and hit create. Do you want to open this project in the current window? I'll say yes, open it on the current window. So you can see now it is going and it is creating an environment. It is bringing all the necessary, references what we need to create the Python project, right? Or to execute the Python project. And you can see that he has created the Python project right out here, right? Good. So we have created the project. Everything is ready. Now we need to go and add some code out here, right? So let us go ahead and add a file. So let us go ahead and add a Python file. So you can see here on the project, I have right clicked and I said add new Python file, and I can say this is lab 1, right? And say okay. Also, I can see that the menu fonts are looking nice, but the code fonts, this is where I'm going to go and write the code. You can see all the Python code files have the extension .py. So you can see I'm trying to write something here, but it is looking very small. So let us again go to file, and again let us go to settings, and this time let us go to editor tab. So let's go to editor tab, and in the editor we have font, and over here I'll just make it like 20. So you can see this is the code fonts out here. Okay, so the fonts now looks better. I would like to reiterate the statement, which I started when I started this course, right? At this moment, this first 1.5 hours, I'm not really trying to go in depth into Python, in depth into algorithm, in depth into R, right? In depth into scipy. What I'm trying to make sure is that, after this 1.5 hour video, you are getting acquainted with the whole ecosystem of AI. You understand the vocabulary, you understand the differences between ML, AI, DS, you understand where Python fits in, what is scipy, what is R, and so on, right? And which are the necessary tools from where to download. So the goal of this 1.5 hour thing is to just make you ready, get you warmed up. And then later on, I have dedicated labs to teach you Python, dedicated labs to teach you R. So at this moment, do not get into too many things, because if you get into too many things, right, in the first go itself, it will make learning more tough, So let's do delay learning. Delay learning means let's learn, the tough part later on, right? Let's first try to execute things and let us see visually, how the project looks like, how things are spanning up. So here it is. You can see this is the comments part. So that is good. Okay, so if I go and type here print, you can see the IntelliSense right out there. I can say this is my first Python code, right? You can see small things out here. He says that I want a blank at the end of the file. That's how Python interprets things. So I'm going to go and press enter, and you can see that error goes off, right? That warning goes off. Now to execute this code, we can click on this run out here, and we can say run. So if you say run down below, so there it is, it says which file you want to run. At this moment, I just have one file. So I'll say run this file, this one, right? And what he does is, down below, you can see I have this small command window. It shows me the output. This is the first Python code, right? In the same way, I can declare a variable here, x is equal to 0. That's how you declare variables in Python. As I've said, later on, I will be having in-depth lectures, right? So this is my first Python code, and let us try to increment the value. You can see small warnings out here. He's saying I want a white space here and a white space here, right? Don't worry. I will explain all of these things, when I do the Python thing. And here I will say plus display me x. Now this x is numeric. If you see at the top, the way Python works, it says the x is is numeric and I cannot really go and concatenate out here. Oh, it is concatenating. Yeah, there it is. It is saying that this X is numeric and please convert it to a string, right? So for converting to a string, we have the str function. We'll use the str function. There it is. And let me again go and run this. You can run from here, right? Or else you can also run from right click and you can run from here as well. So there it is. There you can see this is my first Python code and you can also see the variable value. Now let us try to implement this linear regression. Remember we had done this linear regression out here. Let us try to implement this linear regression using Python. So let us see that can we go ahead and find out the slope and the intercept, using Python. Now, as I've said that in the previous part of the video, that Python is a language. And this language has a lot of libraries. So for example, now if you want to do scientific calculations, scientific algorithms, there is a library called as scipy. Scipy is nothing but it is a library which has all those things, linear regression, statistical formulas, and so on, right? So first thing is we need to include scipy into our project, right? So let us go to file properties and let's go to setting and expand your project. And there is something called as a project interpreter. This project interpreter actually helps you to refer the packages. So I'm going to go here and say add. And what I want to add scipy. Now you can see the word is sky, but it is spelled as scipy. Okay. So I will go here and I will say install package. Now please note that this takes a bit like 1 or 2 minutes depending on your internet connection. So you can see it is installing out here. So once the installation finishes, it will give you saying installation done. So this takes a bit time because scipy is a very big framework. It's a very big package, right? So it will take some time to download. So let us be patient and let us try to install scipy first. So there it is installing. So you can see scipy has been installed successfully and that is great. So if you now go to your project, if you go to your project out here and if you see the libraries, in this you will see somewhere scipy. You can see scipy uses numpy also and other things. We'll talk about that later on. But for now, just, scipy has been installed. It is out here, right? So now the first thing what we need to do out here is we need to first refer scipy in our project, right? So you can see I'm putting comments. So the first thing is you need to go ahead and you need to refer scipy. So to refer scipy in a project, you have to use this import statement out here. So I'm saying from scipy, import this in your project with the name stats. So this is the variable name, by which I will refer the scipy library. And also you can see what I've done is the values of the number of people and the weight lifted, I have put it into an array. So over here, in the next statement, I have imported the values into array. So this is provide the X and the Y values, right? So that is again done. Great. You can see some warnings out here. It is saying this is an unused import statement. In other words, I did not use the stats, right? Great. Now we need to go ahead and take the stats and take this X and Y and try to execute the linear regression. So if you see this stats, it has this function here called as linear regress, which will actually help us to execute the linear regression. So you can see I'm saying here, go ahead and execute linear regression. And in that, the first value is the X array and the next value is the Y array. And whatever is the output, please go and put it into these variables. So you can see here, I have created 4 variables, 5 variables actually. One, which I will get the slope, then I will get the intercept, the R value, the P value, and the standard error. Now at this moment, do not pay attention to these 3 values. When I start getting into internals of linear regression, when I start doing maths and algorithms in the future labs, we will look into it. For at this moment, I just want to go ahead and print the slope, right? So I want to print the slope value and I want to print the intercept, right? So this is my goal. I want to just go ahead and print the slope and the intercept. So again, like this, remember in Python, again, I'm iterating. We don't have to say like var x, var slope. The time you just say slope and you assign the value, the variable is declared and created, right? So I'll say I want to display slope out here and I want to display the intercept out here, right? Good. Let me just exit from this. Yeah. So, okay, so there it is. Let's try to execute it. Let's see if it works or not. So I'm going to go ahead and say run and let's see. Oops, you can see it says that this is numeric and I cannot concatenate it. So remember, we have to use the string function. So I'm going to go ahead and use the string function. Later on, we'll be looking into all the syntaxes. For now, let us try to execute and see the output. And let us try to see that how Python and scipy work together. And again, I'll say run lab 1. And there it is. You can see in the output, it says the slope is 20 and the intercept is 3. And if you remember from the formula, we had calculated the slope as 20 and the intercept as 3. So it is matching to the output, to the values, which we derived from Excel, right? So this was a very simple example of how to use Python, how to use scipy, and how to, implement data science. One more programming language which has gained momentum is R programming. R is a very, very specific statistical programming language created by statisticians for statisticians. It is not a general programming language. So when it started, it never started as saying that we will be creating desktop applications and web applications. So it is not a general programming language like Python, C++, Java, and C#. You can create web app and desktop app using R, but personally I feel there are other languages like Python, C# and Java who can do better work. So what we'll do is, let us go ahead and do the same demo of linear regression using R. So again for R, the same way how we did for Python. In Python, we first install the framework and then we install the editor. In the same way for R, we have to first install the framework and then on the top we have to use an editor, I'll say a studio, right? So go ahead and Google R download and you will find the first link. So go to the first link and you can download here, download R for Windows. Once you download R, you will get a small R GUI. This is not really an editor, but this is a terminal, where you can go and execute R syntaxes. So just type R GUI and you should get such kind of a terminal. So in R, when you want to define a variable, again, like this is not, I'm not going to go and start teaching you R here. In further coming videos, I'll be having separate session for R, but just quickly to make sure that you are able to understand the linear regression formula, the linear regression code. Let us try to just quickly do like 1 or 2 minutes of basics of R. So basically, if you want to go and create a variable in R, you can say str and then say the, this sign out here saying that yes, to this str assign variable test. So that's how you create a variable. And if you want to print this variable, you can say print str and there it is printed, right? So that's how you create a variable and that's how you execute code of R. But now definitely, when you talk about enterprise project, you need a studio, you need an editor. So please go and search for R Studio and download R Studio in your computer, right? So go ahead to R Studio and download this free R Studio desktop open source license. And once you install R Studio, you will be coming out, you will get something like this. You will get this icon, click on it. And now you can go and write R code using R Studio, right? So first thing you can see here, it has opened up. Okay. So let us go ahead and let's create a small R script. At this moment, I don't want to really pressurize your brain with full-blown R programming language, right? I don't want to get into that. So let us quickly create a small R script out here. And let us go and write the code of linear regression using R. So let us go ahead and do the same linear regression problem which we discussed, right, with Excel, and we did the same demo using Python, and now we are doing the same demo using R. So you can see now I have written like 4 lines of code, and this will help us to get the slope and the intercept using R. So the first thing out here, I have defined 2 variables, or I'll say 2 arrays, single dimension array X and Y. So this is how you define an array in R. So you say C, the C is a function, and you pass in the array values, right? And it will go and it will create a vector, a single dimension array. So you can see I've created the value of an array of number of people, and the second one is Y, which is weight lifted, right? And then I'm going and I'm creating a variable called as relation, and I'm using the linear regression modeling. So you can see LM, this LM is a function which invokes linear regression, and here I am saying that this Y will be calculated on the base of X. So this small tilde sign out here indicates that Y will be calculated on the base of X. You can see that R is a typical statistician language, like for example, programmers will say comma X, but like when you say statisticians, they look at the left hand side of the equation and the right hand side of the equation, right? So they look at dependent and independent variables. So here I'm saying that Y is going to get calculated from X. So the tilde sign indicates that, and then we are trying to go and print the relation, right? So I'm going to go and copy this small code out here. All of these codes are available as download on the website. So let's go to our R script, what we have created. So there it is, and let us try to execute it, right? So I'm going to go and select this, and we will say run, right? So let's go ahead and say run, and there down below you can see now he has displayed 3 and 20, which is matching to our Excel values, right? So this was a small demonstration of how to use R, how to use R Studio. So that brings us to the end of this 1 hour of video training, and we have covered all the 18 chapters which we discussed and promised when we started this training. Now I feel that even completing this 1 hour of training is not a small task. So I would like to gift you this ebook, which is a data science interview question ebook. It is a 150-page ebook, which has almost like 100 questions or 100 most asked questions on Python from data science aspect. But to get this ebook, you need to do a favor for me. Please go ahead to this link out here, which is my data science training institute link, in Mumbai, Sakinaka, India. And please put a feedback of this 1 hour of training on this link. And once you put the feedback, please email me that you have put the feedback at questpont@questpont.com, and I'm more than happy to give you the ebook download. And if you're interested to get trained in data science, you can ping me on questpont.com. We will be more than happy to help you. So thank you very much. Happy learning. And now what I will do is I'm going to go and flash a screen, which is a revision screen, wherein I'm going to put all the one-liner points. In one liner, I'm going to go and summarize, whatever we have learned in this 1 hour of video. So go ahead, revise yourself. Please put a feedback, and I'm more than happy to give you this ebook out here, which is the data science Python interview question ebook of 150 page. Thank you very much. Thank you.